Okay, well, overall, people did pretty well in the first exam, or the midterm. It was average of 75%. I was really impressed. I didn't know what to expect, but I can tell you guys are working really, really hard. And if you didn't do quite as well as you hoped, remember the policy is if you do better on the final, it'll replace your midterm score as well. In other words, the final will, instead of counting 20%, will count 40%. So most of you can still get a 4.0 at this point. So keep working hard. I'm sure it'll pay off. It already has for many of you. All right, let me go through this quickly. First one, the difference quotient, or actually I want to find the limit. I want to use the limit definition to find f prime of x. So the one way to do it is to find the difference quotient first and simplify it. And then to get the LCD, it's going to be x squared times x plus h squared. So you multiply this on top and bottom by x squared, this on top and by x plus h squared. Now this h on the bottom, when you divide, you multiply by 1 over h. So that would be a good step right there. Multiply this out carefully, right? Everything that doesn't have an h in it should cancel. The x squares cancel. So you have this, and then you cancel the h. Now, we're not done. This is not the derivative. This is the difference quotient, right? This is the slope of the secant line. F prime of x is going to be the limit as h goes to 0 of this, right? This is the slope of the secant line. This is the slope of the tangent line, right? So if you take the limit, since you've already canceled the h, this goes to 0. You have 10x over x to the fourth, which is 10 over x to the 3. Some people had a little trouble with that. Some people had trouble with this one too. I was kind of surprised. I want one function that satisfies all. Some of you gave me like 5 different functions here. So I wanted one that satisfies all the conditions. There's lots of ways you can draw it, but the limit, notice, f of 0 equals 4, and the limit as x goes to 0 is 4. So it has to be continuous at 0, right? Because if the limit equals the function value, it has to be continuous at 0. But not differentiable there, so a corner might be one way to approach it. And here, the limit has to exist, but it can't be continuous at 2, so making a hole is one way to do it. There's lots of ways, but anyway, most people got that. This one, people had algebra issues with. This expression in here, if you get the LCD, you'd multiply this by x over x. So you get 2 minus x over x, and when you flip this over, it becomes times 1 over x minus 2. You have to factor a negative 1 out of this factor, cancel it, so you get to this, and you end up with negative 1/2. I was really pleased how you guys keep the limit sign on each step. You've really come a long way on that. Let's see, that's the first page. The second page, most people got that we want to use a conjugate on this problem. So you should get 9 plus h minus 9 on the top. 9's cancel. That's a 9. And then the h's cancel. So you end up with this, and then you can use our limit laws. This is 1 over 3 plus 1 over 3, which is 1/6. This one, only about half the people got this. If this is the derivative of something, this has to be f of x plus h. So you know f of x has to have a square root in it, and this has to be f of a plus h. So a has to be there. A has to be 9, because it's f of a plus h, and f of x has to be the square root of x. Furthermore, this has to be f of a also, so the square root of 9 is 3. What's this one? This is where you want to use the product rule. Okay, these are the people had trouble with these. I was very generous in partial credit on these. If you were on the right track, I gave you some partial credit. And I didn't take off much for if you didn't simplify it. I was pretty generous there too. Product rule. If you did not use the product rule, I took off lots of points. So it's going to be the first times the derivative of the second, which is 1/2 times 4 minus x squared to the negative 1/2. Don't forget the chain rule there, times negative 2x. Plus the second times the derivative of the first. I guess I could say times 1. Anyway, so when you end up getting the LCD, which is this, but when you multiply this on top and bottom by square root of 4 minus x squared, don't you just get 4 minus x squared? So this is your final answer. All right, this one, there's lots of ways to do this. I encouraged you in class, when you see something to a power, use the power rule. Some of you wrote it as square root of the top over square root of the bottom. That's fine too. It's just that it's messy here. Here you use the power rule, 1/2 times this to the negative 1/2. And when you take the derivative of what's inside, you're going to use the quotient rule. Bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. So this just becomes negative 4 here. Negative 4, negative 8 I should say. Negative 8 over negative 2, you cancel, I just get negative 4. This is the tricky part. This x minus 4 to the 1/2 can be combined with x minus 4 squared, so you just get x minus 4 to the 3 halves. That's a 3 halves. So I gave lots of partial credit if you didn't get that. But technically, to simplify it, you shouldn't have any negative exponents in your final answer. These ones, this one people had trouble with tan squared of 3x. Doesn't it mean this? So you really have three functions here, folks. You have something squared, so it starts off 2 times tangent 3x times the derivative of what's inside. Well, what's the derivative of the tangent function? It's secant squared of that function, but then it's secant squared of 3, it's tangent of 3x. So a lot of people forgot that little 3 at the end. So you're actually using the chain rule twice, right? Once when you take the derivative of tangent 3x, and the other one when you take the derivative of 3x. Other than that, people did pretty well. This one, we did something like this in class. A lot of these we did problems like this in class. This one, it's going to be 1 over 1 plus this thing squared. The derivative of what's inside is negative 4 over x squared. So this is kind of nifty. The negative 4 multiplies the top, and the x squared multiplies the bottom, you see? So it's going to multiply each term. That's how we get this as our final answer. Okay, last page. People did well on this. This is standard physics type stuff. It says, find the height when the velocity is 80. The velocity is 80 on its way up. When it's coming down, it's negative 80. So you just find h prime of t, which is v of t. You set it equal to 80. You should have gotten t equal 1/2, and then plug that in the height. Most people got that. Find the velocity as it hits the ground. I used to have a problem with this because I used to think, as it hits the ground, well, when it hits the ground, isn't it 0 because it stopped? No. We want to find the velocity as it's hitting the ground, okay? So you set the height equal to 0. I think I dropped a t here. It's not that important because that's the t equals 0. We don't want that t, but there should be a t there. And then this is the t I want, t equals 6. So anyway, t equals 6 is when it hits the ground, plug it in the velocity. You'll notice it's negative the velocity on the way up, right? The velocity on the way up, the initial velocity is right here. The initial velocity is 96 feet per second. When it hits the ground, it's negative 96. I always kind of hoping people would do better on these. I know these are hard. This says, if the limit exists and equals 6, then the function must be continuous there. No, in fact, the function doesn't even have to be defined there, right? So it never says f of 2 exists. It just says the limit exists. So it doesn't have to be continuous. So that's why it's false. This says if the derivative at 2 is 5. Well, hold on, stop. That implies the derivative exists, doesn't it? You're saying the derivative at 2 is 5. That means f prime exists. It's differentiable at x equal 2. Then f must be continuous at x equals 2. Yeah, differentiability implies continuity. That's that theorem we talked about. Last one, if f is continuous at x equal 2, then f prime of 2 exists. No, it doesn't have to be differentiable there. So the absolute value, I actually give you a function that would actually do it at x equal 2, but as long as you mention something about it. Anyway, so like I said, I'm really impressed with how hard people are working. I want you to keep up the good work. I'll post this on I'll post it in the, where should I put this? I'll put it in the announcements folder, okay? The announcements forum. All right, you guys, I'll see you Monday. Bye.